If you see around, you see a lot of poles around. Maybe you can see the flag poles, you can see street lighting poles, etc. These are usually made up of steel. Now the problem with steel is that steel is corrosive. So eventually after some particular time you have to change it. At the same time, steel is not an insulator, so if you're passing electrical cables onto the steel pole, you have to actually insulate it. This is where composite poles can actually help. So composite poles on itself is an insulator. It's a good corrosion resistant, wear resistant material. It is lighter as well. And the fact that it is lighter, you can actually install this pole into the foundations easier and requiring less amount of material and less amount of work. Hence why nowadays we're going into composite poles, the new generation materials that are actually achieving lighter, more efficiency, structural efficiency and cost efficiency. And effectively we are protecting more the environment. So recently we have embarked into a project called Arm the COP, and this project has been conducted by University of Malta and by a small SME, a local family firm, Silvercrafts Products Limited. The project mainly deals with actually developing a machine to produce tapered composite GFRP poles. These are basically being done in order to enhance their structural efficiency, reduce their cost, and actually achieve insulated poles and make them actually more efficient.
This was a project that actually started 15 years ago. 15 years ago we were approached by one of our clients in Saudi Arabia that had this problem to build fiberglass poles which are longer than 16 meters, which were on the market and are able to carry not only lighting poles but also to carry the heavy weight of power supply poles. Back then my grandfather and my uncles found a solution, but we had the limitations of funding and we never came to realize this machine. Thanks to the MCST funding, we were able to realize this project. We approached university, which we work a lot with them, and we decided to go for, first we applied for the vouchers, which were very successful and looked that the project was promising. And then we moved on to the actual build of a prototype machine.
So we have embarked into this project. We have realized that the current manufacturing procedures that there are a bit impossible to achieve poles that are greater than 16 meters. For example, in the case of pultrusion, what we have is we have a situation where we can produce only poles that have a fixed cross-section. And with this, what that means is that you end up with a cross-section big at the bottom and big at the top as well. So you're adding weight and effectively you're adding up raw material as well. Then there are processes called centrifugal machines. The way they actually operate is they actually put in material into a centrifugal machine and they just produce the pole. The problem with that is that the fibers are not oriented the way we want. And like that, we won't be actually achieving the load configuration that we want and the structural efficiency of the pole. The conventional filament winding machines then have also a possibility to orient the fibers in the way we want them. However, the problem with them is that the poles end up to be sagging and effectively they won't be straight. That's where we come in. What effectively we have done is actually produce this machine to produce poles that are tapered, that are actually longer than 16 meters, and that we can actually optimize the way we apply the fibers in any direction we want, any fiber volume fraction that we want, and effectively reduce the material that we need to actually achieve the structural efficiency and the structural loading that we want for this particular composite pole.
The prototype machine was able to give us the confidence to prove the concept that we are able to build very long poles, practically more than 20, 21, 25 meters, and orient the fibers to how we want, which gives us the added value of increasing the strength of the pole and optimizing on the material itself. The way forward for this project is to now actually commercialize the machine. We know that the concept works. We managed to prove the concept. We managed to do some testing that were really positive, and we were able to compare with current poles that are on the market. And we now are aiming to look for investors to build the actual machine.